欢迎来到思想实验室，我是国威。如果我告诉你，台积电也就是台湾的护国神山，它最关键的心脏是 Made in Netherlands， 你会有什么感觉呢？我想很多我们的这个观众呢，应该也知道这件事情啦。没有艾斯摩尔就没有台积电，这句话呢，在半导体业界啊广为流传。我们每天打开新闻嘛，我们包括台积电，对不对？我们录影这一天，这个股价又是冲破高峰哈。那但更有趣的是啊。在2020年，我不知道大家还记不记得，在全球因为疫情大闹晶片荒的时候呢，美国白宫啊马上打电话给台积电，但是台积电接到这通电话，聊完之后一挂上，马上第一时间是打给谁呢？不是打给我们台湾的总统啊，他是打给了荷兰的艾斯摩尔，也就是重要的这个半导体装置的制造商。那这个动作啊，其实就透露出一个很重要的现实，那就是艾斯摩尔跟台积电其实不是单纯的买家与卖家关系，而是一个紧密捆绑的命运共同体。现在的情况就更有意思了哈，这一场发生在美国跟中国之间的科技战争。全世界当然紧盯着台积电，但是真正的主角绝对不亚于台积电的是我们很多人都很陌生的一家荷兰公司。这家神秘的艾斯摩尔，它究竟是谁？那它跟台积电到底是谁离不开谁呢？这个共生关系中间到底是怎么一回事呢？还是说我们引以为傲的护国神山，其实只是艾斯摩尔全球布局之下的一个客户而已呢？我是国威，欢迎来到思想实验室。那今天呢，我们就要一起来揭开这个在美中科技战中最神秘也最强大的军火供应商，也就是荷兰的巨人艾斯摩尔的面纱。今天呢，要聊这个主题，我们非常荣幸邀请到《造光者》的作者一起来加入我们的讨论。最近呢，由天下杂志出版了这本非常重量级的新书《造光者》，那大家可能看书名就知道，引用了最近也非常热门的《造山者》这部纪录片的名字。那我觉得这书名取得非常的好，就让我们欢迎远道从荷兰而来的 Marc Hijink。Oh, welcome.
Well, thanks, Huawei. It's an honor to be here.
Well, it's our honor to have you here. Okay. And are you tired?
Tired is not the right word. I'm energized because I'm overwhelmed by the huge amount of attention for the book. I had great talks, great meetings with a lot of people here around Semicon, but also during my interviews, I heard a lot of new perspectives on the world I'm describing in this book.
Yeah.
And for me, it's always a pleasure to be in Taiwan because it's so energetic and it's also a way of dealing with people, communicating that's very close to my heart as a Dutchman.
Okay. Before we follow our agenda, I want to ask a question. Because in your book, you mentioned that there is a Dutch style of doing business, more direct or more chaotic, which is somehow, beyond my imagination. Mm-hmm. I always thought Dutch people are, very peaceful. But in your book, you describe Dutch people, probably ASML, in a very total different style. Is it real or is it just ASML?
Well, I think the DNA of ASML has a lot of Dutch fury in it from 40 years ago when they started this company. And still it is, even though it has grown bigger to this juggernaut of over 40,000 employees, that it still has this, especially in the engineering departments, this attitude of challenging each other, even challenging your boss, which is kind of counterintuitive, maybe in an Asian culture. For the Dutch, average Dutch is pretty common.
Oh, really?
And you need it if you want to solve the difficult problems, very complex problems that ASML had to solve, for example, to keep EUV running in an economically viable way, because it was a very difficult and adventurous journey for the company. And to do so, you can't rely on the knowledge of just one person. So you need the creativity of a team. And the CTO of Martin van der Brink, I call him the Steve Jobs of lithography. And he had this way of dealing with people in a very direct way. Something I had to get used to as well during the interviews I had with him, because he could be challenging and teasing you, or sometimes...
even to journalists?
Even to a journalist, he doesn't care. He doesn't care about status. He's just teasing you, trying to pull your leg to try to get feedback, to get a response, because that's his inexperience, the way you can create a bit of a chaotic environment, and it spurs creativity. This is not about ego, it's about content. So if you have an idea that might solve a difficult problem, don't hesitate to point it out. If it's wrong, everybody will laugh at you. If it's right, everybody will cheer you.
I see.
And that was the culture that Martin van der Brink created. And I think in the end, that was, I'll describe it in my book. Sometimes serendipity helped ASML over a couple of very pivotal moments in the development of the EUV machine. Sometimes coincidence really matter.
Yeah, because when we think of EUV, such a complicated machine, I will have a weird idea that it must be made by a group of people who are super rational, super peaceful, super,
Zen.
Yeah.
There's no Zen at ASML.
There's no Zen.
No. There's a couple of Zen moments. For example, when they reach an important milestone, but they're not the celebrative type. So the lucky ones get a T-shirt and a photo, and that's it. Because they're very much about. There's a lot of stress, deadline stress to get these machines out when the customer needs them.
When your customers are TSMC and Samsung.
Yeah, Intel, these are the companies that are craving for chip machines at the right moment, at the right time. So if you look at the reason why these customers are so worried about the lithography machine, is that because it's like the crucial element in any fab, or I often call it the oven in the bakery. So it's the tool that everybody needs. It's the central tool, and it's also the most expensive tool. So it's a giant copier for chips, and ASML is capable of creating these very small structures on dense transistors. But its latest generation, high-NA machine, it costs over $400 million. It's to make this machine, actually commercial viable.
Yeah, it's really amazing. And, before we look into the issue of semiconductor, we often treat TSMC as the main character. And we see things through TSMC. Of course, we are Taiwanese. And but now, after your book, we start to see this in a different way, and which is quite very important perspective. I want to know that how did this specific and deeply integrated relationship between ASML and TSMC develop over time? And was it a strategic decision from the beginning, or a natural evolution driven by technological necessity, like the joint development of EUV?
ASML was founded in '84, so that's 4 decades ago. Was during the time, you remember the name of the market leader back then. It was the PC giant, which was it was Intel. I mean, so Intel was the market leader in semiconductors.
Yeah, sure.
Because they had the processor for the PC. Back then, in the PC era, Intel ruled the world. Was made the most money. So the whole industry was trying to challenge Intel. What ASML did when it was founded, it was a daughter company of Philips Electronics, and it was kicked out of the company because nobody wanted to buy equipment, such an important tool as a lithography machine, from a potential competitor, because Philips also made its own chips.
Right.
So Philips had to spin out ASML, reluctant, and the engineers started reluctantly. They didn't like being at this new company because Philips was a very secure employer. So suddenly they were faced with a machine that nobody wanted because it was running on oil, and you don't want oil in a clean room.
Right.
It's messy, and but they had a good alignment, which is the art of putting these layers in a chip right on top of each other without too much overlay. And ASML did that alignment very quickly, so you had a higher throughput. So that was something you could sell, but Intel wasn't keen on changing the litho tools because they were the market leader.
They were dominant.
They were doing fine. So what ASML started with, was reaching out to the challengers of Intel that were willing to take more risk. Back then, the industry consisted of like 10 different lithography makers, amongst others the Japanese, Nikon and Canon. Excellent companies, but ASML started reaching out in a kind of a cowboy way because they had nothing to lose. And They gained new customers like AMD or Micron, mainly US-based, because that's where the market started, Silicon Valley.
Yeah.
But what ASML saw happening was that the market was shifting to Asia, even back then in the 80s, because there was a connection between, now we get to TSMC and Philips.
Yeah.
You know what? When TSMC was founded, Morris Chang, former E3 president, started his pure foundry concept. Brilliant business, but he didn't have any customers and he didn't have any technology. So first he reached out to the Japanese and they said, we don't want a competitor in our backyard. Then he went back to US where Morris had worked at TI. TI said no. Intel said no. And then finally reached out to Philips, which had also built its own technology. And Philips said yes. They took a share of like 28% in TSMC. And when they started, it opened an opportunity for ASML to deliver a first batch of litho tools, because ASML was still very much connected with Philips, as I describe in the book.
Yeah.
Even though they were kicked out of the company, there were still old ties, and Philips felt a responsibility for this nascent technology. And during the first time of ASML delivering these machines to TSMC, well, they're kind of lucky by a bad thing happening to them, because the first batch of machines, 27 of them, they burned down during a fire. So TSMC had to order them again, which was like double money. And it kind of saved ASML from bankruptcy back then. But with the help of a Taiwanese servicing company called Hermes Epitech, which was very essential to first get these engineers to get used to each other. There was a relationship developed between ASML and TSMC. So that started way back in the 80s. And during the 90s, ASML also succeeded in entering the Korean market, because the Koreans were fed up with dealing with the Japanese litho maker, and they wanted to try out something different. And early in its days, ASML had the strategic insight the semiconductor world was shifting to Asia, and the way to beat your competitors is to keep your R&D levels up. So that created a good position for them at, amongst others, TSMC. And what you see happening is that ASML's philosophy was, we don't have to build a perfect machine, but we have to build a machine that's perfect enough to start experimenting, to start R&D, to do data runs, and to get yield and throughput to such a level that you can easily get it to a high volume production. And only companies that were willing to experiment and to take that risk were Asian companies, because, well, Intel was doing pretty good as it was, just leaning on its market share, getting a bit lazy, and too lazy, as we will see. But TSMC really had this entrepreneurial spirit, and the two countries have the same way of communicating.
Maybe chaotic.
It's chaotic, but these engineers got along very well. And I think there was a natural match. Also, if you look at the countries themselves, the size of Taiwan and the Netherlands is approximately the same. But we both have, because we're small, we both have to trade with a lot of other countries. So you have to be able to communicate. And as you know, that's a very important skill if you want to do business. And so you're open to other people's viewpoint. Otherwise, you can't do business. So that kind of open spirit helped the bond between ASML and TSMC engineers.
Like two challengers, they grow at almost the same time.
Yeah,
they need each other.
Definitely. If you look at the market now, you see there are actually two monopolists. So the world is depending for 70% or even more on TSMC's chips as a chip manufacturing. The highly advanced is even
maybe higher. 100%.
I think in the 90s. And ASML is a monopolist in EUV technology, and
probably 100%.
It's 100%. And the DUV market is still about 80 or 90%. So it's a quasi-monopolist. That's why I call it. And with that monopolist situation, you need to be a neutral player. So ASML describes itself, or it wants to be like the Switzerland of semiconductor equipment. as a TSMC is also the Switzerland of foundry because it treats all these customers the same way. And ASML has to treat its customers also the same way. That in common. And I think there's another element. One of the ASML board members told me that ASML and TSMC share the same outsourcing spirit. So if somebody else can do it better, then let them do it, and let us focus on the thing that makes us special on our added value.
Right.
And so the engineers have that in common. And that's also a thing you see in ASML's ecosystem. There's a lot of outsourcing going on. If you look at the value of an average ASML chip machine, 80% of it is coming from suppliers outside of the company. And there's a huge dependence on some partners like Zeiss.
In Germany?
In Germany, they built the optics system, or VDL, which is in Brabant. They do a lot of the insides of the machine. And these are like single-sourced suppliers, so it's vulnerable, but it's also a bond of trust. And you see this, the same relationship between TSMC and a lot of their suppliers.
Right.
Because they're usually single-source suppliers. There's no alternative for ASML, so you have to trust each other. And you can talk business, but this is really a business about people who go back decades often.
Yeah, it's like a evolution of human or any species. If we go back in history or the geological time, anything, even the smallest thing, if it changes, maybe a species won't exist. I think you just described a similar situation. If there is no
spark,
no, there's everything can go wrong. But somehow TSMC and ASML went along and collaborate.
Yes.
Yeah, it's very.
But I must emphasize, TSMC is a very important partner to ASML, but it has the same kind of deep relationships with other customers as well. And if you look, for example, at the introduction of EUV, which is like a big part of this book, how did they get there? How the hell did they get it working? Because it's invisible light. The only natural place to see it is the corona of the sun. So it doesn't exist on Earth.
How build the sun on the ground.
Yeah. So how can you replicate that? So I try to make this invisible visible. And by diving into technology, keeping it accessible also for non-engineers, because I think it's important that people understand what's going on in this world behind the chip in your screen or in behind the chat you have with ChatGPT. So EUV has been a journey that started actually in the 90s in research labs in Japan, in Europe, in the US, and it was actually Intel that kind of spurred the first prototypes of EUV machines.
Yeah, that's why the Americans always said, "Oh, the Netherlands took out EUV, Netherlands took out this."
I think that's the obvious response from American, that if somebody is better at something, they call it, you stole it. But if you look at the historic perspective, Intel was crucial for this initial phase of EUV. And they couldn't get it working. So the prototype, they expected it to work within 5 years. And I also described that pivotal point in time when it was no longer Intel calling the shots about the new technology node the industry was going to use, but it was the Asian companies, Samsung and TSMC. And this all comes down to one meeting in San Jose when the CTO of ASML, Martin van der Brink, describes how he gathers these three juggernauts in one room. Okay, we're not going for bigger wafers, 450 millimeter wafers, which was something Intel wanted. We're going to focus all of our attention on EUV.
That's the funniest part of your book from my perspective.
Okay.
Blink. Get three giants on the same table and ask them to, split the risk. It really happened. Something like this happened.
So if you look back, the industry has been benefiting from globalization, from free trade, from the concentration and improving of efficiency by concentrating on one tiny spot on the planet of Earth, which is Japan, Korea, Taiwan, and now also mainland China. That's where you find the talent, the discipline, the spirit, and the knowledge, and the experience to create chips, because it's not easy. We tend to look at chips as, or computers as, things that say 001110. Don't know if there's any meaning with it in binary code, but there's a lot of physics involved. There's a lot of trial and error involved. There's a lot of human knowledge involved. And I found it fascinating to see that there was this new dimension behind the tools you use without thinking.
When I read your book, I picture it as a Hollywood movie, you know, like, but maybe someday some director will make a Hollywood movie based on your book, because it's very vivid. And I want to see those, you know, like people, Blink or people from Zeiss fighting each other. I want to see a movie about this. Do you want to see a movie like about your book?
I think it's an excellent remark, because when I wrote this book, you know, a lot of business books, they contain a lot of names, a lot of numbers, a lot of writers who put themselves in the middle. And I didn't want to do that. I want to make this industry accessible and visible, even in the clean rooms where nobody can enter, but not only for engineers or people who are already in the business. And for that, I needed my audience to be in my shoes. So that's why I had this ambition to write these scenic moments that you can really just forget about where you are right now and join me in my trip through the industry, through the offices of ASML, in the room where people were shouting or people were building these, making these huge strategic decisions as well. Because ASML is well known for its technology. It's complicated, and they do all kinds of awesome physics stuff, which is all true. But to me, it was also interesting to see what their strategic decisions were. So if you look back at Martin van den Brink, well, actually this week, there was a new partnership announced between ASML and Mistral AI, AI model maker of Europe, most promising AI startup in Europe. And this is like
for me, it's unimaginable.
No, but if you look back, you see that Martin's approach to lithography was, okay, you need a lot of data runs to perfect the output of the lithography machine. And which means you also do a lot of metrology, also a lot of inspection. Well, the amount of data that is being used for this analysis is growing immensely. So if you walk into any clean room or any lab at Zeiss or at ASML, you see, okay, the device itself, the tool itself, and it's surrounded by huge data centers. Racks filled with data, analyzing that stuff to come to that yield to reduce the error rate, because you want the highest yield, of course. For that, you need immense amount of compute. So ASML has been shifting from CPUs, traditional processors, to GPUs. So they are dealing with NVIDIA chips and getting into this next level of analysis. And for that, you also need AI modeling. So you could use a closed model, US model, or you could use an open source model like DeepSeek from China, but ASML, I can imagine why they did. They want to play a neutral role, because these data is highly sensitive. It's about the processes inside the fab, and the fabs want it kept inside their fabs. So they needed to be 100% secure, which means you have to control the model. And that's the reason why they want to be in there. And the funny thing is, I write about the way Martin van den Brink sees AI, or especially the use of like these generative AI, kind of opaque way of decision making. So it's very hard to understand why.
It's in a black box.
Yeah, it's a black box. ChatGPT just delivers answers, and you have no clue how it got to that decision. And for Martin van den Brink, it's not easy to accept, because he's a physicist and he's a math guy. So he wants to be able to compute the models and understand what's going on in the machines themselves, because then you add value, because AI in the end, especially generative AI, is just replicating what's already there. And his vision is, okay, it's a black box. He calls it voodoo software because, well, it's a kind of magic what happens inside. But to really add value, you have to have the expertise, the human expertise to explain what's going on in your machines. Otherwise, you never be able to innovate and to make things better.
Yeah, he's the kind of guy who will tear things apart at childhood.
Yeah.
Right. And I think most of the greatest scientists or inventors, they have similar childhood. They just tear things apart.
I love that anecdote about him. And he was in one of the last interviews I had with him, that he asked him about his childhood, where he was coming from. And he had this appetite, this urge to know what is going on inside. And that's also my urge when I entered the world of ASML. I want to know what's going on inside. And for an engineer, as I understand, because I'm not an engineer, I just know that they're like thrilled when they can find the answer to the why question. Why is something happening? Why is something 0 and why is it not 1? And that's something we never consider when we use our machines.
Yeah. And you mentioned that the key technical challenges, but beyond physics and engineering, I think the biggest challenge lies in the organizational challenge, because ASML, like TSMC, has the same mindset of outsourcing. That will do what they do best. And it's because it's a very complicated machine. How do ASML try to organize and manage such a global network? And I'm especially curious about, are there any components come from China? Or are they all
let's keep the question limited. Okay, first, and back to the organizational stuff. Because it took me a while to find out and to figure out how is ASML working on the inside. So from the outside, it looks like a beehive. You see all these types running around, and it's pretty chaotic and direct. People shout at each other, write emails with exclamation marks, and it's,
like Trump.
But he uses a capital letter, and so it's very dynamic. But if you look at the organization, there's this programs consists of 14 different steps, which is like the first draft of a blueprint of the machine till the NPI, the new product introduction. And the program is sacred, so the rest of the entire organization is folded around that. But to solve real complex issues, and I name a couple of them, for example, when it comes to the light source or getting immersion working or dual stage, you name them. ASML has this way of doing, you can compare to parallel computing. So there are parallel teams working on the same problem, and they also do a lot of give a lot of feedback on each other's work, and they kind of fight over who has the best solution. And so it's not just one engineer figuring out how to work or how to proceed. It's really a dynamic process, and this parallel compute has been growing from day one. So when they started out with 40 engineers, there was no one technical guy knowing every inch of the machine. There was already a team of like 10 or 20. And I think when Martin entered, he was employee number 0. Actually entered when ASML was still part of Philips. I think the team was already like 100 people needed to build this machine. Well, that was in the very early days, and now you see the machine is way more complex, and the processes are way more complex. Much more software is involved. The error rates are way smaller. So the teams have grown as well, but you still see the same organizational structure. So the program is running the things, and I call it program with a capital P, because everybody's we have to deliver. But the organization is set up parallel and very close. It's a dense organization. That's one
a lot of small teams, or
small teams, but also crammed together on a pretty small surface, because the campus is huge, especially for a little town like Veldhoven. But ASML's philosophy is more like Martin van den Brink's way of, well, he hates doing video meetings because you don't see the response, the human feedback when you start shouting at each other, for example. So you have to know what the other people are saying, kind of trying to read you. But if you do a lot of video meetings, if you're spread out over the globe, it adds a lot of noise. And you want the signal-to-noise ratio to be perfect. And to reduce latency, ASML is trying to keep these engineering teams and these research teams together so they can solve problems quickly. So you have different viewpoints on the same problem. From the factory, as I call it, the assembly, but also researchers trying new technology and D&E that are kind of the architects that build these machines. If you spread that over the globe, you add latency and confusion. It's one of the reasons that ASML wants to stay in the Netherlands, because that's where the brains of the company are. And the region is actually called Brainport.
Yeah, it's very challenging because in your book you mentioned that even just one of the part, the laser made by Trump, the company, there are 450,000 components in laser. And it's just the laser, not the whole thing. And it's unimaginable.
Well, if you look at if you would walk into a TSMC fab tomorrow, I won't do that because you probably will shut.
I'll be arrested.
And there's this, of course, the fab floor, the clean room itself, but there are sub fabs, and actually the laser is bigger. The complete laser is bigger than the lithography machine itself, because there's a huge amount of power involved. So I walked around these labs in Ditzingen, also close to Stuttgart in Germany. And there's this company called Trumpf. And they build lasers, CO2 lasers, which you usually use to cut like metal. But they use these lasers to generate enough power to hit a tin droplet of 30 micron in diameter 50,000 times a second. So it's the power of a jet engine taking off, hitting one tiny tin droplet 50,000 times a second.
Per second.
Which
actually is, it sounds like a lie. It sounds like ASML made a lie to cheat all the industry.
Let me convince you. I saw that tin droplet. I was in the labs. I saw it in the labs of Cymer, which is a division of ASML in San Diego. And they have in their research lab, they have a tube. And they pointed me out, if you look at it that way, and they made me like bend my knees, you can see the droplet flowing. But sometimes you see the same effect that if you do like a repetition or beam lighted it in a stroboscope way, then you can see something falling in a very rapid pace. And I saw that droplet, 30 microns, that's visible. But ASML hits this droplet like 50,000 times a second. That creates a plasma that explodes with a temperature higher than the surface of the sun, and that generates invisible EUV light with a wavelength of 13.5 nanometers. So the basics of this technology have been around for years. But for ASML, the challenge was to keep it running, not clogging, like in such a way that chip manufacturers could make money with it. Because initially, the mirrors that are used to project the EUV light that was generated, they clogged with all these tin droplets, like it was waste. And
you need to wash it, clean it.
Yeah, well, actually they do. So I was in the Linkau lab here in Taiwan, where there's one room, and you see these massive mirrors, like I think they cost over $4 or $5 million a piece, and they clean it just with almost with a brush. So it's very easy. But you also see the tin droplets or because if there's too much tin on it, there's less power generated, and they needed power to keep the throughput up.
Yeah.
So it's like a washing machine for your car.
And now I know why there are so many ASML sub companies in Taiwan. They are doing things like this too.
They have to be, because basically TSMC is spreading out over the world. Every other customer of ASML is also spreading out over the world, and ASML has to follow their customers.
Yeah. So let's talk about the geopolitics.
Okay.
Yeah, because it's also a very important part in your book. And just as you mentioned, ASML, like TSMC, they want to be neutral because they are the
monopolist.
Yeah. And if they want to keep their business, they have to become some kind of infrastructure and be neutral. But however, because when the U.S. government start to, or maybe it's a little bit biased, anyway, we saw that the U.S. government imposed strict export controls targeting China. Mm-hmm. And I wonder what is the initial reaction and the internal debate inside ASML. And what's because it's several years ago now. And right now, things also changed. And what's the general reception of this matter in ASML and in Netherlands at large?
Okay, what I describe in the book is what was actually happening behind the scenes. So to the world, it seemed like there was like a ban on EUV for China issued in 2019-2020. What happened was that ASML was never bothered about geopolitics because it didn't matter. The world was globalizing. It was just free trade everywhere. And it was kind of a shock to the company, not in 2018, but actually 2017, when the US first started issuing export controls on its own companies to a Chinese fab. And that was the first time that actually these these were US restrictions, kind of were hurting a semiconductor fab. And ASML started recognizing this might be a problem. And anyway, they did sign a contract with SMIC for the delivery of the EUV machine, the first EUV machine to probably Shanghai. And that was the moment in time when the US tapped the Dutch on the shoulder, say, hey, you know this company that builds this crazy tool that the world needs for advanced chips, for AI, for example, that's delivering to China. Please stop it. But the Dutch, they're part of the Wassenaar arrangement, which is like a multilateral agreement to regulate the export control of dual-use goods, like semiconductor equipment. And so in the Wassenaar arrangement, EUV was also mentioned. The US made sure it was on the list, so the Netherlands could start regulating. But I think the initial surprise was not at ASML; it was mainly the Dutch government that didn't realize how crucial ASML was to the rest of the world.
Really?
Yeah, and so for me, it's we were talking earlier about how overwhelming this week was. And that's one of the reasons is that Taiwanese people and Taiwanese press really understand how important semiconductors are because it's running the country.
Right.
Very important for economics because you have the fabs here. But looking back at Holland, we don't have any fabs, hardly any. Just some old leftovers from Philips. And they probably disappear as well. So the only thing connecting us to the semiconductor industry is companies like ASML. Or ASM International,
yes,
or BESI, which is also a big player in advanced packaging. And I think that's one of the reasons of our success as tool makers, not only the quality or the culture, but also the fact that the Dutch are not competing with their customers. But the result is that it's kind of an invisible world for politicians, because the Dutch politicians on average don't have any clue what's inside their computers, let alone what made these chips and what ingredients you need. That was also kind of my mission to describe this realization of politics, how crucial this industry is, so not right only now, ASML.
Yeah, so right now every Dutch politicians have your book on their desk.
I think many of them have a copy of Focus, but on the other hand, they have switched and they have upgraded their knowledge. And it also is ASML's goal to educate them and to show them how the industry is working. Not only it's the company, but the entire bond of trust and these brittle, very valuable, but very brittle change in supply chain single sourcing, you name it. If you start shaking it, it can easily, stop working. And that's a risk for the entire society. And the pivotal moment, that's where I start my book, is in 2020, 21, when the chip shortage hits. And
the pandemic.
The pandemic. And, there's a lot of emphasis on national security and military usage of AI or chips or you name it, which is all true. But if you zoom out, there's also a need for society to realize that we're depending on chips. And the pandemic was a moment in time for the entire world to realize that our supply lines are very vulnerable sometimes it can happen. We have to de-risk that because we were screaming for more masks, for more ventilators, but we also needed more chips to keep the automotive industry running. But if you look ahead in the future, AI is going to be more important. It's going to be the engine. I describe it often as the OS of real life. So we're going to use it in our self-driving cars, in humanoids taking care of you when you're old. Sometimes. And
I hope so.
I hope. Me too. And so the result is that chips are going to be even more critical for the entire world. So it's not a good thing to be depending on just one small part of the planet for this crucial element of modern daily life. And so it makes sense to de-risk and to de-globalize. And it's my theory that actually the industry has become too successful. So it's now capable of doing all these incredible things thanks to innovation, thanks to globalization as well, because it made the system lean and agile, able to innovate in such a huge pace, fast pace. And now you have to realize, okay, how are we going to use that technology in our daily lives? So we have to protect that.
Yeah, but however, the globalization era has come to an end, just like Morris John said a couple of years ago. And right now, China has their own agenda. They are trying to build their whole supply chain, the whole production.
Domestic.
For example, there are companies copying TSMC. There are companies copying ASML. And of course, we all read from the media, both ASML or TSMC, they will say, they are several years behind us. And but what do you think? Because China did make some serious catching up, and they are actually, pouring all their national resources into this chip war.
Okay, and first of all, I don't think only China has its own agenda. I think there's another superpower with its own agenda as well. So we're kind of, as Europe, we're kind of stuck in the middle, like Taiwan.
Yeah.
But we have these big players within our country, so we have to, act accordingly, so to speak, and also be able to make sure we're heard, that we're a neutral player. We want to stay that way. But Europe, for example, has to up its game as well, because, for example, our export restrictions are still like a sovereign task for every member state, which makes it harder to have a better stake at the table when you're dealing with these superpowers. So in Brussels, you see a lot of things happening to help the Dutch in their negotiations with the United States, for example, but also with China. Now, coming back to China, of course, there's a lot of copying, but I don't think it's only copying. It's also the transfer of knowledge, and you can call it, it's of course often copied in such a way or stolen by cyber attacks. I also describe these elements in my book, but it's very hard to stop transfer of technology or knowledge with humans. So a lot of people, we've seen that happening with ASML's peers, like Applied or KLA. A lot of people worked there and went back to China mainland and started replicating the technology, not based on stealing, but based on their knowledge. And I was in China mainland several times, and I think there's a lot of innovation going on there as well. So it's not only copying, it's also innovating, because one advantage China mainland has is there's a lot of engineers, especially if you look at AI even the US companies developing AI are relying on people with a Chinese background.
Right.
Okay, now zooming into ASML, I think ASML is especially worried about the limitations in China opening up new doors for potential competitors in China. Because there has been competition in China forever. Like this company SME, I also describe it in my book. Well, they bought early generation ASML's machines, tried to copy technology or re-engineer it. And they have a hard time doing it, but they're getting better all the time. But in a slower pace than ASML. And there's a reason for that, because to innovate, you have to do all these learning cycles. This is really like, well, high school.
Right.
Make the same mistakes over and over again until you make less mistakes.
You need to practice.
Yeah, you need to practice, have data runs. So if there's a huge monopolist doing the majority of the data runs, then it's easier to keep that advantage to your potential competitors. But if a competitor gets the ability to learn together with their customers, then there's an opening for new competition. In the mind of the people at ASML, that's their biggest fear, that competition might get a chance in new Chinese fabs, and they probably will. And if you look at DUV, so like the mainstream technology, you see SME, I think the official numbers are like 28 nanometers, or Carry at 65 nanometers, give or take. But it's all of, there's a lot of emphasis on accuracy or these nanometers in international press. First of all, it's bullshit because the nanometer size is way bigger. The actual the pitch is usually tenfold.
Yeah, it's brand already.
It's brand. It's just marketing. Second, there are other elements that are way more important in semiconductor production, which is yield and throughput.
Right.
Because these are like money presses. So if you have a good press that prints a lot of dollars, but often fake dollars, then, well, you can throw them away. So you want to have a printing press that is capable of printing a lot of the right error-free wafers and make sure that it's running 24/7. So if the tool is down like 2 hours in a day, that's not acceptable. No customer will accept that. So you want to have these tool down moments limited. And these are things you can learn over time. So it took ASML 4 decades to get to this level, that you can get to 300 wafer per hour throughput. But once competition starts, it starts from the lower end, and that's the risk.
So, what's in your prediction? Will there be two-sided semiconductor industry? One is the China side and the non-China side.
Yeah, the China and the Western side. Well, interesting question. First of all, I forgot my crystal ball. So it's very hard to predict. Okay. Well, then you predict the future because
it's murky.
I think that's the right expression. It's murky. I think if you look at the ambitions of politicians worldwide, it's to build these domestic technology stacks, and it's more than chip manufacturing. It's also, well, you have to dig deeper. It's also about rare earth. It's also about the data centers and the chips that have to run these data centers. It's about energy.
Yeah.
How do you get are you going to go nuclear like the US companies to provide enough power for these AI data centers? So the end goal is the same. It's about, well, they often describe it as an AI race, but that suggests an endpoint, and I don't believe there is. It's about creating the best circumstances for your economy, for your military, for the benefit of your own people. So that's the goal. And first we had the PC revolution, we had the mobile revolution, now we have the AI revolution. Looking back at Europe, where I'm from, we want our own technology stack as well. So we don't want to be dependent on American big tech companies. We want to be sovereign, but we don't have the tools yet. So there's a ambitious plan. We call it the Draghi report. It's named after an Italian guy, a brilliant finance, but also strategic guy. He says Europe has to spend like 750 billion to 800 billion euros in new technology, foundational technology, chip manufacturing, chips, AI modeling, AI gigafactories. Otherwise, we'll still be dependent on China or US. So we're stuck in between. And it will take a while, especially because the European pace is a bit slower. So there's not one view. So you have to have all these countries aligned. But I think there's no other way, because there are two reasons why the Brussels is on alert right now. The pandemic is one thing that made us realize supply chain is vulnerable. And the other thing is the war happening in Ukraine. Because when the Russians invaded Ukraine, suddenly our energy prices tripled or quadrupled. And it made us see that we were very vulnerable for these energy connections. And of course, now you see that the Chinese have implemented the same kind of export framework as the Americans have, which means they can decide, okay, this country is going to get rare earth as well as, but the other countries are not going to get it. And these things are on the table right now. It's tariffs, it's export controls, it's investment plans. So everybody's trying to find a new deal. And well, if I look at my crystal ball, I agree with you, it's murky. Getting back to China, I talked about this topic with an economist recently, and he said, okay, if China's building its domestic supply chain and its alternative for TSMC, for example, it still has a smaller footprint and a smaller output than the rest of the world, because China is huge, but it's not as big as the rest of the world. So based on the principles of concentration and efficiency, you could argue there will be a less quick pace of innovation. So in his idea of thinking, just comparing sizes, the rest of the world will still be bigger, faster, stronger.
Okay, because people are alerting me that your time is up, but I'll have a final question.
Okay.
After all of the research about ASML, what's the biggest challenge for this company for the next decade? And what is the most important lesson if you want to teach all of your readers?
Okay, well, first they have to read the last chapter, because I wrote an epilogue that kind of sums up your questions. But the gist of it is that the biggest fear, I asked this question Martin van den Brink, CTO, during one of our last interviews, and he said it's our success, that's our pitfall, potential pitfall, getting lazy. And just look at Intel, what has happened, afraid to take any risks, being too happy with yourself because, well, things have always been good this way, it will probably always be successful. Well, nothing is lasts for eternity. And we have a great example from Europe. For example, you remember Nokia, the Nokia phone?
Yeah, sure.
Nokia used to be a market leader. Half of the world was using Finnish phones until suddenly iPhone came 2007 and they were gone. So success can be something you easily lose. So Martin van den Brink's attitude is stay humble, follow your customer, and don't pretend you know it all. And I think that's a valuable lesson also for me.
Yeah. Totally agree. And I think it's also a valuable lesson for everyone, even, of course, Taiwanese, because we sometimes we might be too proud of TSMC's success, even though not everyone works in TSMC or enjoy the successful fruit of this industry. However, still, just as you said, this kind of success could easily confuse people and make people, especially Taiwanese, think that this kind of state cannot be.
It's not forever.
It's not forever.
And well, there's one quote, famous quote by an Intel CEO, Andy Grove, and well, only the paranoid survive. So please go away, stay paranoid.
Yeah, same thing to all of our audience. Okay, thank you, Marc, and it's a wonderful sharing. And there's even more wonderful story in your book, and I really enjoy it. Is of course my favorite book of this year, and I seriously recommend all our audiences 诚挚推荐这本《造光者》给我们思想实验室的所有读者，然后也希望大家读完这本书，或者说没读完没关系，读到一半也可以欢迎留下回馈。如果说有什么有趣的问题，或许我们可以再透过出版社的伙伴来传给你。Maybe we will get some interesting messages and we will forward to you.
Okay, cool. Thanks.
Cool. And thank Marc, and because he's going to heading back.
Yeah,
heading back to Amsterdam, and I'm looking forward to your next book, maybe about Zeiss.
We'll get to that. Thanks, go away.
Yeah, thank you. Okay, and bye.
Bye.
See you next time. 欢迎来到思想实验室，我是国威。思想实验室的 YouTube 会员功能今天起正式上线了，感谢大家一直以来的信任。想邀请最挺我们的你，与我们一起走得更远。有了大家的支持，我们承诺会继续制作更多优质的内容，在未来与大家一起做不同主题的思想实验。欢迎点击下方的加入按钮，与我们一同前行。